Hello, everyone. Welcome to our product teaser event for Tonic.ai's new data augmentation platform, Djinn. We are super excited to show you our latest product offering built by the same team that brought you Tonic. In fact, we've got the makers behind the magic with us here today to demo Djinn's capabilities and to take your questions live. Very happy to introduce Adam Kamor. He is our head of engineering and he holds a PhD in physics. And Anders Steele is our lead data scientist who holds a PhD in mathematics and statistics. And if you've joined one of our webinars before, you'll know I'm Chiara Colombi, product marketing manager here at Tonic. And I'm here to field your questions and to share them with our speakers as they come up. So please do feel free to ask questions at any time. You can post them in the Q&A feature, or I'll also look out for them in the chat. And I can assure you, both are speakers. They love questions, so please don't be shy. All right, with that, I will pass the mic over to Adam to introduce us to Djinn. And Adam, just let me know when you want me to take down my screen share and when you're ready to pick that up.
Sure. Actually, will you go to the next slide? I'm gonna make an offer to the attendees as I'm talking right now. Well, actually, that is not the link that I want. Go back to the original slide. I'll just actually post it in the Zoom chat. Okay. So for those that are interested today, we're going to be giving a demo of Djinn, which is Tonic's new synthetic data platform for data scientists. Djinn is actually hosted at the URL that I've just posted in the chat. And anyone listening today can go to that URL and create an account and actually follow along with what I'm doing today. You can also, after the webinar, connect Djinn to your own data sources and start synthesizing data immediately. Yeah, Casey, that URL will work as well. But this is really, so did you not see? Folks are telling me there's nothing in the chat.
It just went to host and panelists. Let me get that.
Oh, let me do this for everyone. I'm going to repost it. I just sent it to everyone, and it's djinn.tonic.ai !sign up. If folks are still not seeing it, please let us know in the chat, and then I will figure it out again. So I'm going to give everyone a minute or two, right? Just so they can go create an account. There's going to be an email confirmation you'll have to go through. I hope that there's not too many signups at once and things get slow, but let's see how it goes.
I love this, making it interactive.
Yeah, we're going to make it interactive. I was thinking about this a little earlier. I thought it would be fun. And I'm just going to give it another minute or two. And folks don't have to make their accounts now. They're welcome to make them, really anytime in the future. We'll make sure to include this link when we send out, an email after this, just to kind of, touch base with everyone. So don't feel like you have to do it now, but, you might enjoy following along now. That might be fun. So I'll just give it another minute, and then I think we're going to get started. And while everyone's making those accounts, I'm going to actually start sharing my screen and give a little bit of a kind of like a spiel on like why Djinn, how's it different than Tonic, etc. Great. So Chiara, do I need to opt into sharing my screen, or do you do it for me?
I think if I just stop my share.
Cool. And then I can probably go and share.
Yep.
Excellent. I'll share. Neat. Everyone's able to see my this black Chrome tab that I have open.
Yep.
Excellent. Okay. So just, for those just joining now, that link I have highlighted above in my right here, this is where you can go to sign up and create your own account. And while folks are doing that, I'm going to kind of explain what's going on with Djinn. So as everyone here, I think probably knows, Tonic is a platform for generating de-identified data sets. Tonic takes as an input a database, and out the other end comes a de-identified database that structurally, schematically is identical to what you have in your production database, but the sensitive columns have been replaced with fake but realistic looking data. So that output database is devoid of anything sensitive or identifiable to individuals, but it's still useful for testing. The bread and butter use case for Tonic is application and development teams that want to be able to test and engineer new features without actually accessing production data. But with Tonic, they get basically an equivalent to their production database, but it's devoid of that sensitive information. Djinn has a very similar use case. Well, in fact, it has many use cases, one of which, though, is very similar to what I just said, but it's for data scientists. So, we started Tonic 4 years ago, and 4 years ago, we would still occasionally see companies that were just using production data for testing and development. And there's already a trend happening where there is less and less of that. But now 4 years later, there's really very few companies we talk with typically actually give production access to their development teams for development and testing. And they're using Tonic just so they can get higher quality dev and test data. Well, with Djinn, today, what we see with data science teams is that data scientists typically still have access to production for model development and training. And when I say training, I mean really the testing of data science models in their development environments. But there is now a growing kind of movement to kind of begin restricting access to production data for data scientists in their dev environments, just like 4 years ago there was for engineers and testers. So Djinn is meant to give data scientists incredibly realistic looking, and when I say realistic, I mean from a statistical point of view, data which they can use for machine learning, model training, and validation. And it's similar to Tonic in that way, but the way that we accomplish this is very different because we've built it in a way that is meant to allow data scientists to kind of keep their existing workflows, to keep investigating and experimenting within Jupyter Notebook. And Tonic isn't trying to change the way data scientists work, or rather, Djinn is not trying to change that way. So I think I've given everyone enough time to sign up for Tonic. Or to sign up for Djinn, excuse me. So now let's get started with the demo. I'm going to actually just go to this tab over here. So I'm going to be demoing today actually from a different environment. This is one of our demo environments. I've actually already gone in ahead and created a workspace, but for anyone following at home, you'll see when you log in this Getting Started tab, you'll be asked to generate an API token to install these libraries, which you can actually skip steps 1 and 2 for now. And then you'll be asked to create a workspace. You'll have a few options available. For those that want to follow exactly what I'm doing today, please select the pre-canned check banking data workspace. That's going to connect you to a data source, which is the same data source that I'm demoing today. This data source is de-identified information from a Czechoslovakian bank that was released in the late 90s, early 2000s. So it's realistic data. In fact, it is real data, but all of the identifiable information has already been removed. And what we're going to do today is put ourselves in the shoes of a data scientist at this bank. This data scientist has to, do analyses, perform investigations and train models to help the business. One thing this data scientist might do, for example, is build a classification algorithm, which is going to help determine which members of the bank should receive a new credit card offer. So the data scientist is going to, pull data from various data sources at the bank and build a model that's going to, determine, given a user and this information, should we send this person a new credit card offer? And you don't want to send it to everyone, of course, because that's expensive. You want to send it to just the people that you think are likely to accept it. So this data scientist knows what information is needed to train this model. They've already done their feature selection. They've already done all the work. Let's look what they're actually going to do now to train this model. So this is what they determined is the data they need. It's defined by this SQL query right here. And this SQL query results in this result set here. For those that are following at home, if you go to this link right here, you can actually copy that SQL query that I have. So you'll copy here, and I'm actually going to now post this. Let me find my Zoom chat. I'm going to post this. Excuse me. Sorry for the weird view, but I'm going to post this in the Zoom chat. So you can click on that link. And then when you click on that link, it's going to take you to this GitHub guest. You can copy the SQL query. And then when you go back into Djinn on the models page, you can create a model. You copy the SQL here. Oh, I copied the URL, but you'd copy the SQL here, give it a model name, click on run right here to run your model, and then you can save and exit. And then you'll be, or rather than you can save, not exit. And then you'll be at the same point I'm at. So I'll give everyone a second to do that. And in fact, I'll do it as well, just so everyone can get an idea of exactly what I mean. Copy. I'll paste it in here. I'm going to call this new accounts model because I already have an accounts model. And I'm going to save this. Cool. So I've just done this. All right, I'll give everyone a second. Neat. All right. So now that everyone's had a chance to do that, this is the data that the data scientist needs to train their model. But we are trying to get the data science team off of actual production data. So what we're going to do instead is now train a second model. So there's now going to be two models. There's the business model, the model that's answering the question the data scientist has, in this case, whether or not we should send a mailer to somebody. But then there's a model that's going to come before, and it's the Tonic model. This Tonic model is going to take this data set. It's going to train a model that will then generate synthetic rows of data that strongly resemble the data that we can see here. It's a generative model that you as a data scientist can invoke to generate synthetic rows of data, and you can generate an arbitrary number of rows. So all of the real data that you are going to pass into your model for training to determine who should receive an offer or not, instead will now receive this synthetic data. So everywhere in your pipeline where you are passing real data into models when developing and building and training, you can now pass in synthetic data instead. Let's go through what that looks like. So I've defined this model. I'm now going to close. I actually now have 3 models available. Let me show you one other model I've trained, which we're not going to do in the demo today, but I'm just going to show it to illustrate a point. In addition to understanding, actually, let's go back here for a second. In this account analysis model that we were looking at previously, what we really care about here are going to be the relationships between your columns. Like, for a given user, we want to understand, do they have a loan? Do they have a credit card? How many orders are they making a month? Given that you have a credit card, what's the probability that you have a loan? Things of this nature. So when we go to generate synthetic data, we're going to generate rows that are going to have the same cross-column correlations as the original data source. But not all data cares just about these cross-column correlations. For example, let's look at some transactional data. In a transactional data set, yeah, you might care about the correlations between columns, but you care also about the correlations between rows. In this data set, as the data scientists, we're maybe looking at the seasonality trends at the bank, right? We want to understand, how does money flow in and out of accounts per season, or how does the season affect that flow of money? So this data set is actually showing us one row per month per user at per customer of the bank, rather. So every row is the transaction analysis of one user. You can see here that all of the rows that we're looking at right now are for account ID 1. And as we go down these rows, it's showing additional months. So January, February, March, going all the way to December and starting in January again. And as we keep scrolling, we then eventually get to account 2. And every user here has 24 months of data, right? So there's going to be 24 times the number of users at the bank, number of rows in this data set. Now, there's obviously a really strong correlation between rows here, right? As you look at a given account over time, you'd roughly expect the amount of money flowing into and out of the account to really stay the same. Like, there's going to be fluctuations. Things might on average go up or go down over time, but you wouldn't expect to see an account that has plus 10 million one month, negative 2,000 the next month, plus 50 the third month, et cetera, right? Like, most folks are on W-2. They're getting, roughly the same amount of income every month. And assuming they're responsible, they're also spending roughly the same amount every month. Like, some months, you buy the car that you needed for the past couple of years, but in general, it's going to be the same. So there's a really strong, cross row or inter row dependency here. So I'm showing you this model to illustrate to everyone that Djinn actually can handle this cross or this inter row dependency as well as the inter column relationships. When you have this transactional type data, in Djinn, we call this event data. And what you need to do is tell Djinn, okay, well, what is the column that indicates the user? In this case, it's the account ID. And then what is the column that indicates the flow of time? In this case, it's the month. And after you do that, you're set. Both models allow you to tune the parameters. So this tuning it basically tells Djinn how long and how hard to train the models that are going to generate synthetic data for you. These are all, fairly specific and technical parameters that you can use. I think for the data scientists that are watching right now, I think you'll understand what this is. These parameters here are available on both event and non-event models. The parameters down here are event only. So for example, I think for those that are aware, you see this acronym RNN everywhere, which is a recurrent neural network, which should give you an idea of how we're training our event data, right? If that's not obvious. So I have my models trained. I'm ready to start using synthetic data to do work, right? So what we need to do is we actually have to go train the model. So you click here, you click confirm. That's going to train all of my active models. So any model that's active or not active, it's going to train it. How long it takes to train a model is really going to be a function of the amount of data you have. How many rows? How many columns? What are the data types? Is it event data or non-event data? What hardware are you training on, right? For the models that we have today, this takes about 2 minutes to run. This takes about 40 minutes to run on, basically T2X larges in AWS. So super commodity hardware, nothing fancy. But I think here we have about 4,000 rows of data, and here we have closer to 100,000 rows of data, just to give you some very rough ballparks. I've actually already trained some models because I didn't want everyone to have to wait while the models train. So let's actually look at a model that trained. This one, I actually ran this. I mean, it's close to 2 months ago. Actually, it's 2 months on the dot today. When you train a model in Tonic, we actually show you a synthesis report. This is going to give you an idea of how realistic that synthetic data actually looks. Because, there's really two requirements of your synthetic data. One, it needs to look like the real data. And two, it needs to be private. And this report is meant to illustrate, it's meant to answer both questions. So the first thing this report shows is, okay, how do our categorical variables look? How do they compare to the real data? So in purple, we show the real data, and in this turquoise color, we show the synthetic data. These are all of the categorical columns in that account model that we were training. You can see that, yeah, the bar heights are the same for the real and the synthetic data, meaning that, for example, in the data set, the monthly fee value in the frequency column appears about 4,000 times, and each of these are, maybe 100 times or 50 times, something like that. And we're preserving those counts between the real and the synthetic data. And that actually appears to be true for all of the categorical columns that we've trained in this model. You can go down to the numerical columns. In the numerical columns, we can see that there's a great overlap of distributions for the real and the synthetic data. So those probability density curves are going to look very similar for real and synthetic. Now, those are kind of all like, single variable analyses. We can go into a multivariate analysis as well if we want to look at the correlations between all of our numerical columns. So for example, this heat map, what it's really showing are the values of a correlation matrix. And you can see that the correlations are preserved in your numerical values between the real and the synthetic data sets. Real on the left, synthetic on the right. So that kind of gives you an idea of, okay, is the data of high quality? Does the synthetic data look like the real data? Beyond that, we might also care, or we should care, well, how private is the data? Because if the synthetic data isn't private, I mean, there's really no reason to use it. Just go use the real data. You're kind of, wasting your time and making your life more difficult. A lot of folks have this assumption that, well, if it's synthetic, it must be safe and private because, synthetic is like, just generated, kind of through, out of thin air or by magic. But that's actually not true. So it's really important when evaluating, algorithms for generating synthetic data. What are the privacy guarantees or what are the privacy concerns we have? Just to kind of illustrate that point, I could propose right now a synthesis algorithm that's going to generate super high quality data, but the privacy of that data is very, very bad. So for example, every time a row is requested, choose a row at random from the original data set. That's a synthesis algorithm right there, but obviously the privacy of that algorithm is terrible, right? You're going to betray user information. So we care about privacy. This graph here is a distance to closest record measurement. The purple distribution is the distance of every real record to its closest other real record. The turquoise distribution is the distance of every synthetic record to its closest real record. So this is meant to illustrate that synthetic records are basically as far from real records as real records are from themselves, which is a positive sign. You want the turquoise distribution to be on top of or to the right of the purple distribution. In a bad situation, what you would see is a turquoise distribution with a very high bar at 0, meaning a lot of your synthetic records are actually identical to your real records. And really, your generative model for generating synthetic rows is kind of just regurgitating real rows, which is not what you want to see. That would be a sign of bad privacy. So we've looked at our synthesis report. We're happy with both the privacy and utility of the data. Now, what do we do? Well, for any of our models, you have a few options. One thing you can do is actually just click on this code template. This is going to generate a Python script, which you can immediately copy into a Jupyter notebook to start invoking and using your synthetic data. I'm going to kind of skip over this portion. It's kind of just a lot of boilerplate. The real magic is this: model.sample of 100. That is going to return to the user in your Jupyter notebook 100 rows of synthetic data inside of a pandas data frame right there. And then from there, you can take your synthetic data and use it in, all of those downstream cells in the notebook. And you can, continue on with your development. You can continue on with your development. At this point, I'm going to hand it over to Ander, Tonic's head of data science, who's going to show you kind of, what synthetic data looks like to use, how you can use it, and how well does it perform in some real world situations.
Cool.
Excellent.
Thanks, Adam.
And Ander, I'm going to, oh, no, thank you. Let me stop my share. Cool. All right, all you.
Great. Let's see. Let me find the right screen. Okay, here we are. So this is an example workflow using the same model that Adam's trained for this account properties or account summaries to actually, do some sort of modeling analysis. Here we're going to in fact try to predict how much, what's the average balance amount for an account given these other features in this table. And of course, this would be relevant if we're trying to figure out which customers we're trying to target for these promotions. So as Adam mentions, it's super easy to get samples from our data, right? I've already, invoked kind of the magic lines here and grabbed the model for this thing which I've trained earlier. And then again, as Adam says, we just can ask that model for samples. So 10 samples, I get them very fast. This is, a pandas data frame that shows, gives you your synthetic data, and we could even grab real data, which I do below, and take a look, and we see these are, you can't really see that they look the same from this view, but they at least have the same columns and kind of data types, etc. So let's actually kind of dive into how we would use this for answering a real question. And as I said before, we're going to try to, let's just do a simple regression analysis. Here, again, let's predict the average balance amount for this account, given these other features. So there's a lot of boilerplate setup here, but basically, I'm going to predict this target column from these remaining feature columns. In other words, can I get this 60,000? Well, I don't actually know what the unit of currency is for this check bank, but let's say dollars from these other features. And so, you would use this data like you would use your real data. In fact, I'm going to do my analysis in parallel here with the real data and the synthetic data. So there's a little bit extra, carefulness around there. But here, what I'm going to do is I'm going to train just 3 simple regression models. A basic linear regression model, another regression model using a multi-layer perceptron, and then a random forest regression model, all just using scikit-learn. So very, very standard. And we're going to do some basic feature transformations in order to make sure that this data is ready to be consumed by these models. So we're going to use different encoders for the categorical variables depending on the model, and then we're just going to either rescale the numeric columns or pass them through, depending on the model. So I've already done the training because it takes a few seconds, and I don't want to waste time during the call. But the point is that once you've trained these models and then you evaluate them on different validation data, real validation data, you can compare to see how the model trained on synthetic data performs against real data, and compare that with the model trained on real data, evaluated on real data. And so here we have just the R-squared scores for these regression models, and we see quite pleasantly that these are very good models in the real case. So the real model is indicated here with the purple. That's the performance of the model trained on real data, evaluated on a separate validation set of real data. And then turquoise, we have the performance of the model trained on synthetic data, again, evaluated on the same real validation data. And so we see, very similar performance. I mean, obviously a little bit of a drop off in performance here, like the synthetic data has not captured everything. And this is a small data set. So, there's sort of, more room for improvement as your data gets larger and larger. As Adam says, this data set's only, 4,500 rows. So this is what we would consider very tiny. But even in this tiny data set, we see this kind of very nice performance, similar performance, like within 10% of the synthetic model compared with the real model. And so I want to dive in a little deeper there and actually kind of go through some of the characters of this regression analysis. And I'll just pick the random forest model as an example because I think, it's a very, nice, robust class of models. So what I've plotted here are the residuals, or actually rescaled residuals of the model predictions versus the actual value. So the x-axis is the real transaction amount, average transaction amount, and then the y-axis is the predicted, the residual of the predicted amount. So in other words, it's going to be the difference between the real and the predicted amount, and it's rescaled by the amount. And so the point is that we see this nice kind of overall skewness in both the real data and the synthetic data, right? At kind of the lower amounts, we see this very positive error, and the higher amounts, the error tends to be more negative. And this same property, the same kind of qualitative feature of the predictions is preserved both in the real data and the synthetic data. So that's the story. It's not that this particular regression model is very good or very bad. It's that they, are telling the same story. And I think a more, persuasive argument there is let's just actually measure the feature importance here using like these Shapley scores for the real model and the synthetic model. And what's really pleasing is that the features that are important for the synthetic model are also important for the real model. In other words, like, the story that the synthetic data tells about these accounts is extremely similar to the story told by the real data. So we can use this in place of the real data for this type of exploration. But you can do something more with the synthetic data that you couldn't as easily do with the real data. And this is kind of the data augmentation strategy. So I'll motivate this as follows, right? Like one of the important features for this, both these models, the real and synthetic, is the flag of whether or not this account has a credit card, which makes sense, right? Like, having a credit card means the account balance is probably going to be higher. Okay, so if we actually look at the distributions of look at the distributions of the this has credit card flag in the real and synthetic data, I mean, we see approximately like a quarter of the accounts have a credit card in both these real and synthetic data. But maybe like, this data, which we have, is not representative of the population which I'm interested in for my production models. Maybe instead, like I expect that the population I'm targeting is more evenly split. And in fact, like, we expect it to be kind of even odds whether that person has a credit card. All right, so what can we do? Well, like obviously we would want our models to reflect that, and we would want to train models on data that's as close to our production environments as possible. So one thing we can do is we could actually just use this synthetic data model that we produced and build the kind of distribution that we want. And so, for example, here I'm using this conditional class, and this is going to, we can specify how many members we want with credit card being true, and how many members we want has credit card equals false. And so that is going to go in as kind of seed, if you will, for the conditional model. And then we're going to go generate a bunch of samples. And so this will take a second, and then we'll kind of inspect it, see what the samples look like, and see what that does. So once that finishes, then what we'll see is that we'll roughly have the same even split. I mean, it's still a little noisy because, again, these are probabilistic models, and this is what we're asking for, but we're not guaranteed to get it. But this is much better than the kind of 3-to-1 or ratio that we see over here. So if we actually go and plot this, like maybe one of his average transactions amount, we can see the nice shift in this feature between the real and the synthetic data. Okay,
While you're doing that, I will jump in with a quick question. You've had such a rapt audience that not a lot of questions have come in, but I do have one for you now. And either of you can answer this, Adam, as well. We have someone in the audience who is already working on adopting Tonic into their secure cloud environment that does not allow external calls as containers. And they're wondering, is Djinn going to be available for on-premises deployment?
Yes.
I'll answer that. Yes. I think I'm not going to say who asked the question, but yes, I mean, it sounds like you're already a current Tonic customer, and you'll be able to deploy Djinn in the same way that you deploy Tonic, and the same guarantees hold in terms of running in air-gapped environments.
Thank you.
Sure.
Okay. Thank you. And now I've finally invoked the correct magic, and my plotting works again. So we can see that, in this new rebalanced or augmented data set, we have this much higher kind of, second bump or second mode here of transaction amounts. It's a little hard to see in this side to side. So I think the kind of overlapping comparison is probably maybe the easier thing to see. So basically in the synthetic data, this augmented data, which is in turquoise here, we see this shift rightward in the transaction amount, which is what we expect. And so you could then use this augmented data, as part of the model training. We could go in, redo this whole analysis, just plugging in the, synth data to be the augmented data here, and run everything, and you get similar looking results. I don't think that will illustrate anything at the moment, but the point is that you have this fine-grained control with this synthetic data that allows you to generate new samples, more than just kind of oversampling the real data. And so this is a powerful form of data augmentation that you can use for your modeling.
While you're talking about using this for data augmentation, there's another question that I do have for you. And Adam, you kind of touched on this within the UI. You showed kind of the configuration that's possible. Could you speak to how much Djinn users can turn the dials of privacy versus utility within the product?
Yeah, definitely. Like, the longer you train the model, basically, and the more capacity you give the model, the more it will capture your data, which is a double-edged sword, right? Like if you're exactly reproducing your source data, which I mean we're not doing here, then you have you violated the privacy of the entities in that data? Yeah. So basically, you can kind of determine how much you really want to get close to the source data, more or less by increasing these parameters and training it longer and harder. And then you can evaluate the privacy of that data based on that. The reporting gives you a sense of how much did this synthetic data model actually memorize of my original data set.
That's right.
And so in these examples, what we saw was a good case where we didn't in fact memorize the underlying data, which is what we're going for.
There's definitely an element of needing to do hyperparameter tuning once you've kind of defined what your models are, so that you can do essentially what Anders said. I mean, you train for some amount, you check your synthesis report, you check your own analysis. Okay, what's the utility? What's the privacy? And the goal is you want as high utility as you can get while still maintaining whatever privacy standard you have based off the use case. Actually, for those that have created accounts, next week, expect some really, really neat UI updates to Djinn that are going to start making it a lot easier to plug Djinn into, various like hyperparameter tuning services that are out there. And you'll see these changes come to our Python library as well as to the UI itself. So for example, those customers already using Andrew. What is it? Is it weights and biases?
Yeah, weights and biases is a great way to do your hyperparameter search.
That's right. So for those using tools like that, you'll be able to integrate them into Djinn very shortly.
Another question for you about what works with Djinn on the other end of it. What data sources are currently can you work with? Can you connect to Djinn to?
Sure. So I think today, Tonic supports many different databases. With Djinn, we're adding databases as requested. So I think the databases we support today are Postgres, MySQL, and Snowflake. With that being said, if those in the audience are excited to use Djinn with their own data sources, and you have a data source that I did not mention, reach out. You can reach out to info or support at Tonic.ai. You can email me personally at adam@tonic.ai. We can add data sources to Djinn with typically just a 1 or 2 day turnaround. So we're happy to add additional data sources as they become requested by customers.
Great. I also have another question for Ander to kind of geek out on the data science under the hood. And this question has often come up on previous webinars that weren't even Djinn related. GANs versus VAEs. I feel like GANs get a lot of the love out there in the data synthesis space, and we've used GANs in the past, but now we're using VAEs. Why is that?
Yeah, well, generally speaking, VAEs are a little easier to train. The problem with GANs, in my opinion, is that the loss curves aren't really interpretable. You're training 2 models in tandem, and they're fighting against each other. The generator and discriminator, and sort of understanding the story of the model progress through these curves is difficult. Whereas with things like variational autoencoders or other types of models which have more straightforward like actual loss functions, then it's easy to kind of do these types of hyperparameter searches that Adam was talking about. You can infer a lot from the loss curve, so they're easier to train is one advantage.
Okay. Yeah. I always love hearing kind of your nuanced interpretations of the what's under the hood. Question for you, Adam. You talked early on about how Tonic and Djinn differ as products. Could you talk to us about how they pair? Why might an organization need both?
Sure. So, organizations typically take on Tonic because they need high quality testing data for their engineering and test teams. And that comes in 2 flavors. One flavor is this team is currently using production data for dev and test, and they can't do that anymore. We're seeing less and less of that. The other flavor is we stopped giving them access to production years ago, but our dev and staging environments suck. They just are not representative of what's in production. We need better data. So, Tonic can be for these companies either a privacy company, getting off prod, or a dev efficiency company. We're already off prod, but we need better data so we can do our jobs more efficiently, right? You can be either. Djinn is very analogous in that way. We're starting to see organizations restrict access to production data for data scientists. So for those companies, Tonic is also a privacy company. For the companies that are ahead of the curve that have already restricted access for data scientists, they're struggling with what to do. Like how do you train models when you don't have data to train, right? That's a very tricky problem. And not only how do you do it without having data, but how do you do it without having really, really good data? And that's where Djinn comes in for those companies as well. So I see it as very analogous. The one thing that Djinn has that I think that Tonic doesn't is this data augmentation use case, which Andrew was just kind of demonstrating. Yes, it's a privacy tool. That's awesome. Data privacy is important. But also we have customers using Djinn that actually privacy isn't really their main concern. Their concern is we have a data set. We know it is not representative of the customers that we actually care about because, this is overrepresented. This is underrepresented example. They use Djinn actually for synthesizing additional records of underrepresented data so that they can kind of shift the bias of their data to make it more representative of the population they actually care about. And that is a really exciting use case. That was one, frankly, that I don't think we really anticipated when we started building Djinn. We were focused mostly on the privacy, but like I'd say, like when we chat with customers, that is equivalent to the privacy use case when we chat with folks. So I think that's a really exciting, addition to something that like is not, that doesn't really have a Tonic analog, I guess. Yeah.
Okay. Yeah, and the privacy component is important now with regulations, the shifting landscape of regulations. But for the data augmentation component, what have teams done historically to solve for this? Because it seems like something that they would have wanted to have had a solution in place previous as well.
Sure. I mean, there are like, I don't want to say like hacky, but there are like rudimentary things one can do if you need to kind of, rebias the data. For example, you can just copy, you identify the group that's underrepresented. You copy the rows, you duplicate the rows, so you can kind of, up their counts. That's going to lead to problems when training models, though. However, and it's also like, yeah, you can do that. It's not ideal from like a statistical point of view. But also it's like, it's work. It's hard to do. You're constantly going to be doing it. And just having a tool that can make it easier to do, but also do it a heck of a lot better is of value to organizations.
Yeah. That kind of reminds me of another question that I wanted to ask Ander.
Sure.
If there's a particular experience that you've had in your career that made kind of a fundamental difference in how you approach this problem of data synthesis for data scientists.
Yeah, I think there are a few papers that have kind of opened my eyes along these lines, because I used to be very much, just oversample the underrepresented class. There you go. Why not? I mean, is data augmentation actually going to improve the performance of your classifiers or regression models in robust ways? And the answer is yes, actually it will. It's more than just calibrating your models to the new source data. You can actually get robust improvements from using synthetic data. I mean, this older paper, SMOTE, the synthetic minority oversampling technique, is a good example of that. And then there's other examples, like seeing an example where a healthcare company has some data of basically they're trying to classify whether someone is going to have experience some sort of adverse outcome based on these kind of small samples of small number of samples, and they're trying to better match the their labeled data to their production environment. And they see, basically, by using these kind of synthetic data techniques for their training augmentation, they see like very clear robust improvements in their classification models on like real test data. So it's impressive what this technique can actually accomplish.
Yeah, I mean, I really do feel, the more I'm hearing you both talk about this, that this is just truly the cutting edge of data science right now. We have another question that just came through from the audience. The demonstrated privacy metric is the only one to see if privacy is guaranteed. Academia use attack models. This is kind of long, so you might want to read along with me if you can see it in the Q&A.
Yeah, Andrew, this is for you.
Yeah. Use attack models to derive the privacy risks, such as membership, attribute re-identification, and inference risks. There seems a gap here. And how small is the distance between the two privacy histograms, real and synthetic, is small enough for data sharing? Do you have suggestions, insights?
Yeah, that's a great question. Kind of, there are multiple parts here, so I'll try and take it piece by piece. So right, like these attacks, these more like intricate analysis of privacy risks, like membership inference and attribute inference attacks. Yeah, these are kind of key ways of understanding, quantifying what are some of the risks in your data. Like, or I think they typically are used in the context of some sort of downstream model, like a classification or regression model. What does that model expose about the people in the training data? What sort attributes can we infer from those, that model? Can we infer whether someone was in the data set, the training data set or not? And so a lot of the techniques, I think, for investigating these types of risks are posed primarily in the case where you have this kind of classification or regression style model rather than a generative model. But of course, you can do this type of analysis on the synthetic data, or at least the downstream models that you've trained with the synthetic data. Like if you have your classifier or your regression model that you train, then you can plug it into the same black box techniques to kind of evaluate the try to estimate these empirical risks. But these things are non-trivial computations and could take a while. And again, they're only estimates. Like they're giving you examples of what these attacks could accomplish, but they're not really giving you strong bounds. So yes, I mean, there's like more you can do. The kind of there's computational cost to doing these, and you have to formulate in the right way. But if that's the concern you have about the use of these generative models, then we can definitely talk and actually help like formulate that for you and work with you in your evaluation. In terms of, see, the question has disappeared, and so now I can't actually see the remaining parts. But
sorry, if you might see
it's on the answer tab if you go there.
Got it.
Yeah.
Cool. Right, and there's another question, like how do you actually interpret like this, distance to closest record graph, and that's that can be a hard question. Like, is it okay if the synthetic record reproduces a real record? Maybe that's not an acceptable leakage, even though that could happen by random happenstance. I think these privacy graphs are very useful when you're comparing multiple models, and you can sort of evaluate the relative risks of these models, as well as sort of like getting a sense of obvious failure modes. Like if you have a large clump of synthetic records that are identical to real records, then that's clearly a privacy failure. But then trying to interpret that graph more generally, we can give you some benchmark or some suggestions, but it often depends on exactly what the context for this data is. Like, is it private healthcare data, or is it records that aren't really sensitive at all?
That's right. A lot of Djinn's users, in addition to relying on the synthesis report, also rely on their own analysis done on these output models in their own Jupyter notebooks. So like a common workflow we'll see is they train their Djinn model, and then they immediately put it into their analysis notebook where they will run their own reports both on utility and privacy. Also, one of the in the Tonic UI on that getting started page, there's that instruction to do a pip install on the two Tonic packages, Tonic API and Tonic reporting. The Tonic reporting package has the ability to essentially regenerate that synthesis report for you in Jupyter Notebook. So you can do a more careful inspection of the data directly in Jupyter Notebook.
Andrew, you kind of mentioned this a couple of times during your answer around the support that we provide. You can always reach out to us with questions. Could you speak, either of you speak more specifically to what support we provide for Djinn users?
Yeah, I can. I'll speak to that. So for Djinn users, and this is true for Tonic as well. Really, we don't distinguish from a support point of view. All customers of Tonic and Djinn actually are given access to their own private Slack channel where they'll be able to communicate directly with Tonic engineers. For Djinn, it'll typically be myself, Ander, and then potentially someone else from Ander's team. And you'll just be able to ask questions, get feedback. Maybe we'll have suggestions on the model you're feeding in and where we can improve it. The privacy is too much, it's not enough, etc. So it's a really white glove approach. I think anyone that's kind of curious about trying Djinn, I encourage you to reach out. You can use our self-hosted version if you're comfortable doing that. And if not, then you can reach out and then we will. And Kiara, it's actually Djinn.Tonic.ai !sign up, not Tonic.ai.
Oh yes, sorry about that.
It's okay.
I'll fix that.
I'm just letting other folks know in case there's confusion. And then, but for those that aren't comfortable using the hosted environment, you can actually deploy Djinn entirely on your prem. You can even install it on air-gapped machines if you wish. It's installed via a Docker container. We can provide Docker Compose and Helm charts, so you can really get up and running with Djinn on your own environment where the data does not leave your prem. In a matter of 10, 20 minutes. It's a pretty straightforward install. But I encourage everyone to go try it out in our hosted environment. We even provide sample data sets for you to play around with, so you don't really need to connect to your data on day one. And again, for those that are interested, it's Djinn.Tonic.ai /signup. And you can get started right away.
Should be correct now in my.
That looks good.
Apologies for that.
Yeah, the question mark's optional. Actually, no, the question mark's not optional. You need to have it there.
Yeah.
So yeah, that link is the good one.
Great.
Excellent.
I think I've only got one last question for you as we come up on the end of the hour, and it's a forward-thinking question, but I always love to ask it. What is next for Djinn? Are there additional data types or data sources that we're aiming to support? Anything like what are you most excited about next?
Yes. I mean, we constantly add support from data sources as they come in by customer request. I can't tell you what we're going to add next. What we add next is whatever's requested next. Mm-hmm. And really, that's to us, that's just like that's bread and butter right there. That's not really such a big deal. What I'm excited for though is the new functionality we have coming out related to making it easy to do hyperparameter tuning. We are also going to be expanding our synthesis report a good deal, especially including new graphs to really help users understand the quality of the event data that they're synthesizing. I'm excited for that. We've been toying around, and this actually goes to the last question that was asked. We've been toying around with additional privacy metrics that we can expose to users. I think the distance to closest record graph is a good one, but it certainly there is room for improvement, as was already kind of noted. What else? That's definitely the short term. Andrew, anything that you're excited for that I didn't already cover?
Well, I mean, medium term is the text data.
Oh, that's right.
Synthetic text.
That's right. Yeah. I mean, everything. I mean, and I think this is obvious to everyone on the call. I mean, we're showing you this with structured or semi-structured data. We have some exciting technology that we're researching, and I think researching is definitely the right word here. Related to kind of just the synthesis of text data, unstructured text data. Think doctor's notes and product reviews, chat logs between individuals, etc. And I don't want to give a timeline for that right now. But if there's anyone on the call that's super interested in that, you should reach out and we can talk about it, really anytime. Maybe you could be, one of our, early adopters of it. I think that would be exciting.
Awesome. There's a lot more to be excited about than I was expecting with the answer to that question. Because already just Djinn being new and is super exciting. So
yep,
thank
absolutely.
You. That's great. All right. Any last questions? Well, we're here. You've got them live. Feel free. I think we've covered everything. Well, thanks to everyone who joined us today. This was great. Always love seeing Djinn demoed, and I always love talking with you both about all the science behind it. Thank you, Adam. Thank you, Ander. You've got the sign up page right there. You can also reach out to us. You can reach out at Djinn@Tonic.ai. As Adam said, you can also reach out directly to him, Adam@Tonic.ai. We'd love to hear from you. To everyone who signed up, let us know your questions along the way. We'd love to hear what you think. Any feedback, please just reach out at any time. And we look forward to seeing you at the next event.
Wonderful.
Thanks, everybody.
Thank you. Thanks, everyone. Bye.